Assalamu alaikum, everyone. Any questions before we start? Just an announcement we'll be having a test, inshallah, on Sunday. The timings have been announced on the website. So you'll have a slot of about 30-35 minutes, and we'll have a brief test covering the transport layer. So transport layer ke andar what we've covered till today's lecture, all of that will be included, inshallah. Right, any questions? We'll just wait 1 minute and then we'll start. Okay, so in the last lecture, we talked about TCP, and we said that TCP is a point-to-point reliable in-order byte stream protocol, which provides reliability to the application layers. And whenever the application layers wish to transfer data which is reliable, they always use TCP in the internet. It's a protocol that was built a long time ago, and it stood the test of time. So it has a number of sort of different artifacts which are built in, which ensure that you're going to have a reliable in-order byte stream delivered to the application layers above. Now, we started talking about the TCP header. And to understand the TCP header, basically, we need to look at the TCP header structure. It's organized into 32-bit words or 4-byte words. So you have a source port, which specifies the port address of the transmitting or host, whereas the destination port is the port number of where you would like to connect to. Then you've got two interesting fields, which are called the sequence number and the acknowledgement number. Both are 32-bit fields. And what they do is basically they represent the byte number of the data that you are transmitting. Okay. Now, ye samajhne ke liye, what you have to understand is that suppose you had data to transmit. Okay. And that data is, you can think of that as a continuous stream of bytes. And what we're then going to do is we're going to number these bytes. Okay, so the first byte is byte number 0, then you have byte number 1, and so on. And ye sare ka sara file you had, it has to get transferred from host A to host B in the exact same sequence, in the exact same order. Now, if you sort of broke up this data into, let's say, segments, and you transmitted these segments, and you numbered these segments, that was one possibility. जैसे कि हमने पहले पढ़ा कि आपको datagrams को या packets को, you simply number them and you send them through. And because you've numbered them, you know, okay, if a packet is lost on the way, then that particular packet number or segment number is missing. So that would be one way of doing it. Okay? But why do you think that we instead of numbering the segments as segment number 0 and segment number 1, हम numbering relate कर रहे हैं to the data number or the byte number contained in the segment. So we're referring to the sequence number as the byte number of the first data in that particular segment. Any thoughts on this? Why not say segment number 0, segment number 1, segment number 2, and send that through like that? Why use a sequence number which relates to the byte number? So agar ye segment aap bhej rahe hain, theek hai, and the first byte is byte number 0, we'll call this a segment with sequence number 0. अगर ये segment आप भेज रहे हैं, let's say the first byte over here is byte number 79. So we'll call this segment with sequence number 79. Any thoughts on that? Ji. Right, so we have in the chat. So for the case that we're missing a byte along the way, you wouldn't really miss a byte along the way because आपने bytes को एक container में रखा है and you've transmitted that entire sort of packet or datagram or segment in one go. So ऐसा नहीं होगा कि बीच में कोई byte missing हो जाएगा. I mean, bytes would get corrupted, but if the packet goes missing, the entire set of bytes is going to go missing. It's the question simply is that we have two choices. एक तो ये कि आप numbering जो कर रहे हैं, that is based upon the segment number. So you say segment number 0, segment number 1, segment number 2, and each segment contains a number of data bytes. हमने यहाँ पे जो segments हैं, उनको number किया हुआ है regarding the first byte that they contain. So for a wrong sequence number, what does that mean, Ali? Can you explain that? Question समझ रहे हैं? I mean, the choice that you had would be just like in the past we've numbered these packets. Packet number 1 भेजा, फिर packet number 2 भेजा, फिर packet number 3 भेजा, and so on. So you're numbering the packets. Packet number 1. Now that packet could contain 100 bytes, 150 bytes, 300 bytes, or whatever. ठीक है? But we've simply called it packet number 1. What we've done here is we've assumed that you have a byte stream. इसको आप chunks में तोड़ रहे हैं, लेकिन जो आप segment की numbering कर रहे हैं, that is based upon the first byte contained in the segment. ठीक है? There's a hint here, and the hint is that if you think about it, you would like to traverse the internet across multiple hops. Now, it is possible that as your packet goes along the way, it comes to a network where the segment size that you have transmitted cannot be forwarded. ठीक है? तो उस केस में क्या होगा? So you have a maximum segment size. Let's say you have a packet जो 1500 bytes का है, and along the way, hop by hop आप traverse करते जा रहे हैं networks को. एक ऐसी network आती है जहाँ पे आपका maximum जो frame size है वो छोटा है. So what will have to be done over there? Well, you'll have to split up this packet into smaller packets. ठीक है? Now, if you did that, and if you had numbered the segments originally, कि ये segment number 1 है और ये segment number 2 है, और रास्ते में you had to maybe chop up the packet into smaller segments, then your numbering would get messed up. It would go haywire. ठीक है? So that's why rather than numbering the segments as 1, 2, 3, and so on, what you're doing is you are numbering the segments based upon the byte number of the first data bytes that they contain. उस तरह से आपको ये पता चलता है कि you don't really need to worry about कि अच्छा originally भी यही segments भेजे गए थे या बीच में कहीं रास्ते में they were broken up. As long as you have the byte number and you know how much data is contained in each of the segments, you can then put together those pieces and recreate or reassemble the exact same byte stream as transmitted. ठीक है? Is that clear? Does that make sense? जी. Any questions here behind the logic of numbering the segments based upon the sequence numbers? So essentially what you're doing is you have TCP data, G. So basically you're कर हम ये रहे हैं कि ये आपके पास एक TCP data है, ये segment है, which let's say for example contains byte number 0 to byte number 80. ठीक है? So जब आप इस segment को भेजेंगे, you will specify the sequence number of this segment as sequence number 0. ठीक है? Because the first byte is numbered 0. अब लेट्स से नेक्स्ट एक आप सेगमेंट भेज रहे हैं जो कि 81 से लेके 160 तक है, ठीक है, उसको आप नंबर करेंगे विद सीक्वेंस नंबर 81, ठीक है. So that sequence number refers to the bytes number of the first data byte within that segment. Okay. So rather than numbering those segments as segment number 1 and segment number 2, you're using the sequence number, and the sequence number simply refers to the byte number of the first byte within that segment. So आपको ये पता है कि अच्छा इस सेगमेंट के अंदर जो पहला बाइट है उसका ये नंबर है, ठीक है. आपको सेगमेंट का लेंथ पता होगी बिकॉज in the header field you basically you have you know what the length of that is going to be, ठीक है. And then subsequently जो next segment होगी उसमें you know the sequence number of the first byte that you have over there, and from there you know कि अच्छा इसमें data कहाँ से शुरू हो रहा है, and then you can put those segments together on the receiving side. Right? So any questions here? Right? Anything unclear over here? कि ये sequence number क्या चीज है? Sequence number simply is a method of numbering the segments such that you are referring to the byte number of the first byte contained in the data part or in the payload of that particular segment. Okay. Okay. So basically what you have is the segment is sent when basically the segment is full, which is typically you're going to fill up this data to a maximum segment size. And sometimes if it's not full, but you need to send it straight away, then the application might trigger that, and when the data is actually pushed by the application, to aap data ko bhej denge. So remember that you have a application layer which is sending data to the transport layer for sending down through the network layer and the frame layer down hop by hop across the internet to the receiving side. तो जब ऊपर से application layer data भेज रही है आपको, यूं ही आपके पास let's say you've decided कि जी based upon the network hop by hop दरमियान में जो भी network support कर सकते हैं, you have a maximum segment size of let's say 1500 bytes or so. So as soon as you've received 1500 bytes, you're going to transmit that particular segment. ठीक है? That's one thing. Secondly, ये है कि अगर ऊपर से application आपसे कहती है कि जी data भेज दें, it pushes for that. Then of course you're going to transmit the data even though you have less than 1500 bytes from above at that particular point in time. ठीक है? So basically, the sequence numbers refers to the byte stream number or the byte number of the first byte in your segment's data. ठीक है? And जब आपके पास ये segment receive हो जाएगा, तो आप sender को एक acknowledgement भेजेंगे. ठीक है? And the acknowledgement number is going to be the sequence number of the next byte that you expect from the other side. ठीक है? So let's say you have been transmitted a segment. You have just received a segment जिसका पहला byte number 0 है, and it contains 81 bytes. So last byte number है 81. So on receiving this, host B will send back an acknowledgement, ठीक है, with acknowledgement number 81, which means that the next segment it expects is going to start from 81. Because पहला segment 81 bytes का है, 0 to 80. अब जब ये segment यहाँ पे पहुंच गया, you're going to acknowledge back with acknowledgement number 81, telling the transmitter कि अच्छा अब जो next receiver को 80 तक सारे के सारे bytes ठीक तरह पहुंच गए हैं, अब जो आप next data भेजेंगे, that is going to have byte number, that should be byte number 81. That's the next byte that the receiver is expecting. Okay, so acknowledgements are cumulative. ठीक है? The receiver is telling the sender कि कहाँ तक उसको ठीक बाइट्स पहुंच गए हैं। ठीक है। Now, when the receiver receives a segment such that, let's say, जब इसको ये मिल गया 80, now this is expecting 81. Now suppose के 81 तो नहीं मिला, वो रास्ते में कहीं है या अभी गुम गया है, and कोई अगला segment इसको मिल गया. So let's say the next one was starting at 160 or 200 or somewhere else. So it's expecting something. It's expecting a segment number which is starting with byte number 81, but instead it receives something of a subsequent number. So फिर क्या करेगा? Well, the TCP specification doesn't tell us exactly what it should do. It has two choices, basically. एक choice तो ये है कि it could ignore that segment entirely, simply drop that segment, but that would be inefficient. The second thing that you can do is you can buffer that segment, okay, and you can keep it with you until you get this missing data. And once you get this missing data, then of course you're going to acknowledge both of those, और अगर आगे से मजीद भी आपको मिल गए हैं, तो जहां तक आपको contiguous data मिल गया है, वहां से वहां तक आप उसको acknowledge करके वापस भेज देंगे. ठीक है? So if you receive an out of segment, an out of order segment, then based on the implementation, most implementations for efficiency are going to buffer that. ठीक है? वापस आप एक acknowledgement भेजेंगे जरूर. So even if you receive something ahead over here, आप फिर भी acknowledgement जो भेजेंगे उसमें you will say you're going to acknowledge sequence. The acknowledgement number is going to be 81. ठीक है? Telling the sender कि 81 80 तक तो ठीक मिल गई उसको, the receiver is expecting 81. तो ये मिलने पे भी आप भेजेंगे acknowledgement number 81. उसके आगे वाली डेटा मिलने पे भी आप acknowledgement number 81 ही दोबारा भेजेंगे. So in other words, if you receive an out of sequence or an out of order segment, you will send back a duplicate acknowledgement number. ठीक है? You will send back a duplicate acknowledgement number. So receiving a duplicate acknowledgement number at the sender tells the sender that the receiver is receiving segments, but it is receiving segments that are out of order. ठीक है? So we'll just remember this, और ये फिर आगे हम इस्तेमाल करेंगे while we're talking about congestion control, that when you receive multiple sequence acknowledgement numbers with the same number, multiple or duplicate acknowledgement numbers, so then what does that indicate, and how do we go about handling that? Okay. So if you look at your buffer, once again, if you have packets which are sent and acknowledged, they are shown over here in green. So your window is beginning from this yellow one over here, and it contains both yellow and blue. Yellow refers to those packets which are in flight, which have been sent but have not yet been acknowledged. Blue are those जो कि आप भेज सकते हैं लेकिन अभी आपने भेजे नहीं है. And of course, जो विंडो की बाहर चीज है, उसको अभी आपको इजाजत नहीं है भेजने की. You cannot transmit these ones. So this is a sending side window. Now, when are you going to be allowed to transmit any of these gray ones? When the window is going to slide forward. When is the window going to slide forward? When you receive an acknowledgement कि ये जो in-flight packets थे, ये पहुंच गए हैं. अगर आपको let's say in bytes की acknowledgement मिलती है starting from here, तो फिर आप विंडो को स्लाइड करेंगे? Yes or no? जी. Will you slide the window if, let's say, you are expecting an acknowledgement for this byte number here, ठीक है? Whereas you get an acknowledgement for something over here, will you slide the window? No, you will not slide the window. Instead, what you will do is you will simply know, okay, an out of order segment has been received by the receiver. ठीक है? And अगर आपको before you time out, you receive this particular acknowledgement of this particular acknowledgement number आपको ये मिल जाता है, फिर तो you know कि अच्छा all the way up to here सारे के सारे packets आपको सही तरह मिल गए and you slide the window forward. अगर नहीं मिलती, then of course you're going to retransmit the particular segment starting from this particular byte number. So this is the Windows base, okay? And this only slides forward once you receive an acknowledgement that a segment starting from here has been successfully received by the receiver. Okay? So this, अगर मैंने मजीद कोई पैकेट भेजना है, ठीक है? Yes, we are using sequential numbers for this. अगर मैंने next segment भेजना है, तो उसका sequence number ये होगा. It's this byte number of this byte number is going to refer to the sequence number of the next segment that you're going to be transmitting. Okay? And when I get acknowledgement back, okay, the acknowledgement number, that acknowledgement number should refer to this byte number over here. If I get that, then I know, okay, that particular segment starting from here, वो आपके पास सही सही पहुंच चुकी है, ठीक है? And then I can slide this window forward, ठीक है? Now the question is कि how should we number these bytes? ठीक है? एक तरीका तो ये कि we always start from 0, ठीक है? लेकिन उसमें there are certain security problems in that, because if you always start from 0, ठीक है, then what can happen is that because you always start from 0, दो चीजें हो सकती हैं. एक तो ये कि some user who is not supposed to be transmitting data, or some sort of malicious user could connect to that particular. So you have a client and a server, so it could connect to that server using that initial sequence number, the same one, because you know कि हमेशा 0 ही होगा, ठीक है? So basically you can initiate a connection because you know what the initial sequence number is going to be. So इस चीज को avoid करने के लिए कि a client which is not supposed to connect, some malicious client, okay, sets up a connection to a server and sorts of sends data. You use a random initial sequence number always. So whenever you begin a new connection, you always start with a random number. The other thing that can happen is that, let's say आपने sequence number start किया, 0 से start किया, ठीक है? If you always use 0, you started the connection and let's say the connection broke, and next time you restart that connection and you start with the same number, which is 0 again, okay? So then the server will not be able to distinguish between कि अच्छा ये पिछला connection कोई है या ये कोई नया connection है, ठीक है? So if the sender is the same and you're using the same sequence numbers always, then you will not be able to distinguish between a previous session and a new session. So for this reason, okay, the initial sequence number that you use is a random number, okay, a random 32-bit number, and you always start with a random number. Okay, usse ye hai ki it serves two purposes. It sorts of allows you to discern कि ये एक नया connection है, and it ensures that people who are not connecting वो भी connect नहीं कर पा रहे, because if they knew what your initial sequence number is, everyone would always initiate new connection starting with 0, and the server would have no way of discerning कि ये अच्छा ये वही है या नहीं है. So you always start with a random initial sequence number. इसी तरह से, this is a connection. So you'll have a sequence number for data going from host A to host B. You will also have a sequence number for data going from host B to host A. And both of these are going to be different numbers. Okay? So as an example here, we take a simple scenario of a protocol called Telnet. ठीक है, ये पुराना protocol था, and Telnet करता ये था that it allowed a client to connect to a server, and you could then on a terminal type in a command, and the host would actually, the server would respond to that command. Okay? So you could remotely log in into your with a terminal to a machine. So you put in your username and password, you log in, and let's say आपने कोई फाइल वहां से ट्रांसफर करनी है या कोई और एक फाइल एक डायरेक्टरी से दूसरी डायरेक्टरी मूव करनी है या जो भी आपने कमांड्स देने हैं using Unix, you could do that remotely using a terminal. Now it's not used any longer because जो भी आप डेटा भेजते थे, including your username and password, that was not encrypted. It was clear text. So anybody sitting in between, anybody eavesdropping could actually see your exact username and log in because the data was typically sort of encoded with ASCII. ASCII, as you know, everyone knows what the sort of agar ek data pada hua ASCII ke andar, so everyone can read that. So your username and the password, all of that was sort of clear text, and everyone could read that. But the way it worked was that on your screen over here, so on your console over here, you would type something, and when you type something, okay, on the keyboard, it would be transmitted from this host here to this host here, and that data would echo back. And once you got that back, then it would be displayed on your screen. So after this round trip time, जो भी चीज आप type कर रहे हैं on your keyboard, that would get displayed on your screen. And when you hit return, that command would actually get executed. ठीक है? So let's say host A and host B के दरमियान एक connection setup है. आप C type करते हैं on your keyboard. So that C is going to echo back. It's going to go from host A to host B and then come back. Now, when you're transmitting data, this is just 1 byte of data. So we're using the sequence number 42 for this data, for example. So just for example, suppose कि इस data का जो initial number है, sequence number है, वो 42 है. And you have 1 byte of data. So once this goes through and comes back, the host is going to acknowledge that C उसको मिल गया, and it now expects data starting from number 43. तो अगर आइंदा आपने कोई चीज भेजनी है, that should have sequence number 43. Now, acknowledge 79 over here tells the host B that अगर आपने कोई चीज भेजनी है, तो I am expecting that with number starting from number 79. ठीक है? So sequence number refers to ये जो data A से B जा रहा है, उसका number क्या है? And acknowledgement number tells us that I am expecting data starting from 79. So when host B sends back that same, echoes back that same data to host A, it does so with sequence number 79. Okay? And it tells it, I'm expecting the next data byte to start from 43. So sequence 42, acknowledgement 79, data C bheja aapne. This is going to come back by saying sequence 79, which is the same as this one number over here. And it's going to then say, it's going to acknowledge 43, that the next byte that it expects is going to start from 43. And you've sent 1 byte of data, which is C. Host. So ये जब इसको echoed C वापस मिला, it's going to show that on the screen, and it's going to send back this segment over here, which is going to start with sequence number 43. And इसमें acknowledgement number आपके पास, that is going to be 80, which means कि आइंदा अगर आप data भेजेंगे, that's going to start with 80. So this sent packet here, इसका sequence number is going to be 80. Okay? So is this scenario clear? Any questions regarding ये जो numbering है? ये A से B 42, so B से A will be 43. ये X 79 बता रहा है इसको, therefore ये जो data यहाँ से भेजेगा, इसका sequence number 79 होगा. Okay, so it's a two-way connection. So you have two numbers, one from A to B, वो 42, 43 इस तरह से आगे चलता जा रहा है. The other from B to A, वो 79, 80 इस तरह से आगे चलता जा रहा है. Okay? Any questions here? So this is a simple telnet scenario where you're echoing back whatever you type over here, it's getting echoed back from the other host, and it's only 1 byte, very small data जो कि वापस आ रहा है वहां से, and इसको आप फिर स्क्रीन पे दिखाते जा रहे हैं. At the end, when once a command complete हो जाती है, you would press enter, and then that command would get executed at the other host. And in some sense, it would give you some feeling कि round trip time आपका क्या है, because आपने type किया, it would not appear on the screen straight away. It would sort of take a while round trip जब तक वो echo नहीं होता from the host to actually appear on your screen. A few hundred milliseconds at times. Okay. Especially if you telnet it across the Atlantic, then it would take quite a while. Right, so any question here, Ji? Okay. So then the next discussion that we're going to talk about is about the round trip time and timeout. So we've talked about how do you know that what you've transmitted might not have got received. Well, you transmit something, you start a timer. If you time out, you're going to retransmit that particular segment again. But the key question is that what should be the value of the timeout? There's two problems here. If it's too short, you prematurely time out, which means that you're going to have too many unnecessary transmissions. If it's too long, you have a slow reaction time to the last segment, or you send a segment, अब आप इंतजार कर रहे हैं कि एक वापस आए, एक वापस ही नहीं आ रहा, और आप उसको retransmit अगर जल्दी नहीं करते हैं, so obviously your connection is going to be very slow, it's going to be very inefficient. So the question is that how should one estimate this round trip transmission time? How should one estimate the round trip transmission time? Now notice that you're developing a protocol which potentially is going to work on the internet, and you could have host A in one country, host B across multiple continents, multiple countries. Hundreds of बीच में hops हो सकते हैं, tens of hops हो सकते हैं बीच में. So you have to come up with a robust end-to-end protocol which is going to handle this. So how do you estimate RTT, the round-trip transmission time? Well, you need to measure the round-trip transmission time, okay? And that for each time you transmit, you're going to get one measurement. That is going to be your sample round-trip transmission time, okay? Now, अगर आप एक segment भेजते हैं और वो ठीक से पहुंच जाती है, आपको एक वापस आ जाता है, and ये एक ही दफा हुआ, that you sent a segment once and you got the ACK back straight away, that is a good metric for an estimate for your round trip transmission time. Whereas agar aapne segment bheja, it didn't get through, you had to then retransmit it. So you would want to ignore retransmissions, because a retransmission only takes place when the segment got lost on the way, suggesting that there was congestion. Okay? Or other reasons. I mean, तभी time out हुआ तो फिर आपने retransmit किया. So basically, your round trip transmission time cannot be accurately estimated when you're having retransmissions for that particular segment. So you'll ignore retransmissions, okay? And you will only measure the round trip time for segments which have been acknowledged correctly first time. Okay? Now, suppose you get these values, these blue dots over here refer to your sample retransmission times. And each time you sort of transmit, notice a variation आएगी. Okay? There's a lot of variation that's taking place over here. Okay? Now, in order to estimate what your actual round trip transmission time is, okay, you will want to use these sample values, and based upon that, come up with some estimate for your round trip transmission time. Okay? Now, अगर तो आप sample value itself को ही आप as an estimate इस्तेमाल करें, and this is going all over the place, it's fluctuating a lot, your estimate is also going to fluctuate a lot. Okay? So each time you get a new value, let's say उसी value को इस्तेमाल कर लिया, as your sample round trip time को ही आपने estimated round trip time के तौर पे इस्तेमाल कर दिया. So then that's not very intelligent, and your estimated round trip time is also going to fluctuate in exactly the same manner as the actual measured values. So how can you come up with a better estimate? ठीक है? Well, what you could do is average this. So let's say आपको बहुत सारी values आ रही हैं. If you average that, that would give you probably a better estimate of what your actual round trip transmission time is. ठीक है? लेकिन अगर आप सारी वैल्यूज इस्तेमाल करें फॉर एवरेजिंग, ठीक है, एंड बीच में कहीं कंजेशन थी या वो कंजेशन खत्म हो गई है या पहले कंजेशन नहीं थी अब कंजेशन आ गई है, so then your estimated round trip transmission time, if you're using all the values, will not be a very good estimate. ठीक है, it won't be very accurate. ठीक है, so what strategy could you use? Well, you could use any thoughts. क्या करें? How do we come up with a good estimate for your round trip transmission time? Now, one good way of doing this is कि जी आप कहते हैं अच्छा जी I'll have a window. So let's say I take 10 values and use that an average of the last 10 values. Now, when I get the 11th value, I drop the first value. So I have a moving or a sliding window which is taking an average of the last 10 values. That's one way of doing it. ठीक है? Now, you could do that. You could make a bigger window or a smaller window, and each has its pros and cons. But one thing that you could do is that you could give a different weight to different samples within the window. And a smart way of doing this is probably giving a higher weight to the most recent sample as opposed to the older samples. Okay? So that's called a weighted moving average window. A weighted moving average, because the most recent value को आप ज्यादा वेटेज दे रहे हैं एंड पुरानी वैल्यूज को आप कम देते जा रहे हैं, एंड जो आपके पास नई वैल्यूज आती जा रही हैं फॉर योर राउंड ट्रिप ट्रांसमिशन टाइम, योर सैंपल आरटीटीज, ठीक है, what you're doing is that you are reducing the weights of the previous values and giving a higher weightage to the most recent value. So what you have over here is one way of doing this is that you have, let's say, that your estimated round trip transmission time is equal to 1 minus alpha, where alpha is some value. It could be, let's say, 0.125, which means that up 87.5 या 0.875 weight दे रहे हैं to your previous estimate. So for every new value that you get, you're calculating a new estimated round trip transmission time. So जो आपका previous estimate था, उसको आप weightage दे रहे हैं 87.5% की, and ये जो नया sample RTT आपको आया है, उसको आप weightage दे रहे हैं, let's say 12.5% की या 0.125 की, and notice that the sum of this is still 1. So it's because if you added these two and they did not sum up to 1, तो फिर तो वो ठीक नहीं होगा, because then you're not weighting things correctly, and over time this is going to sort of, your sample RTT and your estimated RTT will not have the same will not have the same sort of size. Over time वो फर्क पड़ जाएगा. So whenever you do any weighting, you have to make sure that ये जो दो quantities आप weight कर रहे हैं, the previous estimated RTT and this new value, the sum of the weights has to be 1. ठीक है? So a very common thing that is done in statistics is आप एक factor ले लेते हैं and you say अच्छा नए sample को, नई sample value को मैं ये weight देता हूँ, उसको आप typically कम weight दे रहे हैं, ताकि ऐसा ना हो कि one random off sample बहुत ज्यादा या बहुत कम आपके estimate को बिल्कुल ही skew कर दे, and जो पिछला estimate है उसको आप 1 minus alpha weight दे रहे हैं, ठीक है, which is your previous estimate. So your new estimate is equal to your previous estimate times 87.5% and 12.5% आप weight दे रहे हैं to your latest sample. Now, if you did something like this, then of course, okay, yes, sample RTTs are these blue values over here, whereas these purple values over here is giving you the estimated RTT. And you notice that as the sample RTT is growing, the estimated RTT is also growing. but it's not fluctuating as wildly as the sample RTTs are. इसमें fluctuation आ रही है, लेकिन इतनी ज़्यादा नहीं आ रही है. So this is a good or an estimate for your round trip transmission time based upon individual sample RTTs. ठीक है? इसकी logic समझ आ गई. This is one algorithm of doing it. You could use other algorithms. ठीक है? But this makes good statistical sense. People have sort of tried other things over time, but this is a solid way of doing things and is commonly used in a number of different areas whenever you want to estimate something from samples. This is a standard commonly used technique. And what it does is that the influence of past samples decreases exponentially fast if you did something like that. Right? So any questions here? Okay. So आपके पास एक सैंपल आरटीटीज है जो फ्लक्चुएट कर रहे हैं, उससे एक स्मूथर एस्टिमेटेड राउंड ट्रिप ट्रांसमिशन टाइम आपने निकाला, ठीक है? And now what you're doing is that based upon the deviations, ठीक है, between the, so you want to find out that okay, ये जो estimated round trip transmission time है, इसके साथ you might want to add a safety margin. ठीक है? So whatever your estimated RTT is, plus some safety margin would be a good value for your timeout interval. ठीक है? Now, one way of doing that is to have your estimated RTT plus a safety margin. Now, safety margin हमने ये रखी यहाँ पे कि 4 times the deviation in your RTT. ठीक है? So deviation का ये है कि अगर deviation आपकी थोड़ी है, so then this number here is going to become small. And your estimated RTT is going to be what your RTO is. I mean, with a safety margin, of course. ठीक है? Sorry for that. तो अगर आपकी deviation ज़्यादा है, of course, तो उसके बाद फिर ये है कि what's going to happen is that if your deviation is greater, then of course, what will happen is that this safety margin is going to be bigger and bigger. ठीक है? And deviation क्या है? Deviation once again is the difference between your sample RTT and your estimated RTT. ये difference. इसको भी once again you could have used that as a deviation, but then you could also exponentially weight your deviations. ठीक है? कि your previous deviation को आप 1 minus beta weight दे दें, and your current deviation, which is your sample RTT minus your estimated RTT, इसको आप beta से weight कर दें. Notice this is once again a weighted sum. It's the same formula as the previous one. You're using just a slightly different value of beta. You could use a different one as well. But here is deviation RTT, which is basically exponentially weighted deviation in your round trip transmission time. और इसको आप इस्तेमाल कर रहे हैं with a safety factor over here, as a safety factor over here, and that is giving you a value for your round trip transmission time. So ये वही बात है कि अच्छा ये आपकी सैंपल आरटीटीज भी वेरी कर रहे हैं, उससे आपका एस्टिमेटेड आरटीटी आ गया. अब एस्टिमेटेड आरटीटी एंड गिवन सैंपल आरटीटी का जो फर्क है, that difference is your deviation in your round trip transmission time. And then you're looking at, okay, that difference in the, which is the deviation in the RTT, उसकी एक smoothed value आप लेके उसको as a safety margin इस्तेमाल करें. And you want sorry. Sorry for that. Okay, so that's a good estimate for your timeout interval, which is your estimated round trip transmission time plus a safety margin. And the safety margin depends upon the deviation in your round trip transmission times The smaller the deviation, of course, the tighter this round trip RTO is going to be, the closer it's going to be to your estimated RTT, because agar deviation kam ho rahi hai, then you're getting a very good connection. The round trip transmission times are almost the same. And then what's happening here is that आपके पास जो है the timeout value जो है, if it's as long as it's the estimated RTT plus the safety margin, it's going to be an accurate estimate. And then whereas अगर आपका connection जो है वो congestion wildly ऊपर नीचे जा रही है, तो उसका मसला ये है कि then your timeout has to be larger in order that you're not transmitting too prematurely or too late. Any questions here? Yeah. So this depends on the network traffic, network congestion के ऊपर फर्क पड़ेगा, ठीक है? And of course, as the network congestion changes, then these values are going to change. But basically, what you can measure is the sample RTT. From different measurements of the sample RTT, you want to come up with a smoothed value, which is called your estimated RTT. And then ये जो smoothed value है and the actual sample RTT, इसमें जो difference है, that is your deviation in the round trip times from sample to sample. वो जो deviation है उसकी एक smooth value आपने ली, and you're multiplying that by 4 to give you a safety margin, and adding that to your estimated RTT to get the timeout interval, and that's a reasonable estimate for the timeout interval. I mean, it's a compromise, because what you want to do ultimately is you don't want to time out too prematurely, or you don't want to time out too slow. You want to come up with some value in between, which gives you good efficiency. Take it. Now, you can't use sample RTTs. And why is that? Because they're going to randomly fluctuate. And you don't know if the ACK is for the original packet or the retransmitted packet. Dono cases where you need to track that. So, जब आपके पास एक retransmitted packet आता है, ठीक है, तो then don't use the RTT for a retransmitted packet, ठीक है, उसमें ये है कि जब भी आपके पास time out होता है, so the new RTO is calculated as 2 times the previous RTO. So let's say आपने time out 1 second रखा हुआ था and you time out. That means that गड़बड़ हो गई है. The packet was lost along the way and you've timed out. So what you can do is you can simply set your new timeout value to be twice the previous timeout value. Okay? And then you can start calculating the new values based upon your sample values. ठीक है? और उसको आप adjust करते जाएंगे slowly. ठीक? But अगर timeout हो जाता है, then of course you simply back off and double your timer value. Okay? And you keep on doing this until you receive an ACK for a packet that has not been retransmitted. Uske baad aap, you're then going to recompute your RTO based upon the previous formulas, the algorithm that we've shown, and you're going to continue with that. So that's a good estimate for how to calculate your timeout. Okay. So this is how it's done in practice. Okay, so TCP protocol, as we have seen, is a protocol where you're building reliability on top of an unreliable service. Segments को आप pipeline fashion में भेजते हैं. So just like you've seen the go backend and the selective repeat protocol, उसी तरीके से यहाँ पे भी it's not stop and wait कि आपने एक segment भेजी and जब तक उसका ACK वापस नहीं आया आप अगली segment नहीं भेजेंगे. You have a window. It's pipelined. So you're transmitting multiple segments. ठीक है? You have packets in flight. जो उनकी acknowledgements आती जाती हैं, आप window को आगे slide करते जाते हैं. So in that sense, it's a pipeline protocol. The ACKs are cumulative, ठीक है? And Selective repeat may, if you remember, we had a different timer for each one of the segments that you transmitted. Go back and may you had only one particular timer which corresponded to the to the oldest unacknowledged segment. यहाँ पे भी you have a single retransmission timer. Now this retransmission timer is triggered by timeout events or by duplicate acts. And initially, if we consider a simplified TCP sender, we're going to ignore duplicate acts and flow control and congestion control ko we'll ignore for a moment. Usko baad mein we'll talk about. So TCP sender events kya hai ji? Whenever you receive data from above, you're going to create a segment with a sequence number. The sequence number, as we've discussed, is the byte stream number of the first byte in the segment. And you're going to start a timer if already not running, and you're going to send that segment across. So the timer is for the oldest unacknowledged segment. So let's say आपने एक segment भेजी, timer start कर दिया, दूसरी segment भेजी, तो timer already चल रहा था. That corresponds to the oldest unacknowledged segment. तो अगर already चल रहा था, तो नई segment भेजने पे आप timer को restart नहीं करेंगे. Already चल रहा है, ठीक है? अगर वो पिछली वाली जो सेगमेंट है वो एक्नॉलेज नहीं हुई फॉर वट एवर रीजन, ठीक है, एंड द टाइमर एक्सपायर्ड, ठीक है, then a timeout has taken place. When a timeout has taken place, you retransmit the segment that caused the timeout and restart the timer. Acknowledgement अगर आपको रिसीव हो जाती है, if that acknowledgement corresponds to previously unacknowledged segments, तो आप अपडेट कर देंगे. It's a cumulative act. So you know कि अच्छा यहाँ तक डेटा सही पहुंच गया है. So you will update the base of your window. You will slide your window forward. And अगर अभी भी there are still unacknowledged segments और आपका timer जो है वो चल नहीं रहा था, you will start the timer. ठीक है, on basically on getting this acknowledgement, on receiving the acknowledgement. Okay. So if they're still unacknowledged segments, you're going to start the timer if they are still unacknowledged segments. ठीक है. So सबसे पहले आप next sequence number को set करें to the base, to the initial sequence number. Sorry, आप next sequence number is the sequence number of the next segment that you're going to transmit, and that is going to be set to your initial sequence number. Base को आप set करें to the initial sequence number. ऊपर से जब data आएगा, you'll create the segment, and its sequence number is going to be the next sequence number. ठीक है? So first packet, first segment के लिए you're going to start with the initial sequence number. जितना data है, the length, you're going to add that to the sequence number and update the sequence number. So let's say पहला sequence number 100 था, and you had 20 bytes of data. The next sequence number is going to be 120. ये आपने update करके रख लिया, ताकि जब next packet भेजेंगे, you're going to use sequence number 120. If the timer is not running, you're going to start the timer, और आप इंतजार करेंगे ACK का. अगर ACK नहीं आती, time out हो जाता है, तो you're going to retransmit the not yet acknowledged, अभी तक जो भी not yet acknowledged segment है, with the smallest sequence number, उसको आप दोबारा भेजेंगे. ठीक है? You're only going to retransmit one segment which has the smallest unacknowledged sequence number and restart the timer. अगर आपको ACK receive हो जाता है with a certain value, then based upon that value, you will compare that with the base, send base. अगर ये value send base से बड़ी है, तो आप send base को update कर देंगे. Send base को आगे slide कर देंगे. In other words, you're going to slide the window forward. ठीक है? And if there are currently not yet acknowledged segments, you're going to start the timer. Otherwise, if this corresponds to the last segment that you have transmitted, on receiving this, you're going to stop the timer. Okay. So notice that on receiving any of these segments, okay, you're going to restart the timer. Okay, starting time. Okay, unacknowledged segments hai, on receiving each, you're going to start the timer again. So here are the interesting scenarios. आपके पास host A है, host B है. You've sent 8 bytes of data from host A to host B, starting with sequence number 92. So 92 से 8 bytes 99 तक जाएंगे. The next byte it's going to expect is going to have a sequence number of 100. So ये जब ACK भेजेगा वापस आपको, it's going to ACK 100. Okay. Now suppose ये जो ACK था ये it got lost along the way. So timeout takes place. When a timeout takes place, the sequence number of the last unacknowledged or the segment which has the smallest unacknowledged number is 92. So आप इसको दोबारा भेजेंगे. You go to retransmit this again. ठीक है? This time ACK 100 is retransmitted over here and it's received by this host A over here. So if you were to send further data, it's going to start with sequence number. It's going to start with sequence number. Anybody? It's going to start with sequence number 108. No, not 108. देखिए ना? Sequence 100, exactly. It's going to start with sequence number 100. Okay? So notice 8 bytes are going to be numbered from 92 to 99. ACK 100 is telling host A that the next number that I expect is 100. Okay? ये तो उसने कह दिया कि I expect 100 और ये रास्ते में गुम हो गया. इसने दोबारा पुराना ही भेजा. जब इसको पुराना मिला तो ये फिर कहेगा कि अच्छा जी the next one that it's going to drop that because it already has a copy of that. It's going to drop this new segment, but it will reiterate to the sender that the next segment that I expect should start with number 100. Okay. Okay. Now here's another scenario. This time आपने 92 भेजा with 8 bytes and उसके फौरन बाद एक अगली segment 100 with 20 bytes भेज दिया. ठीक है? So notice you can do pipelining. I can transmit 2 segments one after the other. How do I number them? 92 से 99 पहला वाला है. ये 100 से 119 तक है. ठीक है? That's what I transmit. Now, if I were to transmit a next segment, I'm going to start with sequence number 120 from host A. ये मिलने पे ये ACK 100 भेज रहा है. ये मिलने पे ये ACK 120 भेज रहा है. ठीक है? लेकिन ये ACKs आने से पहले ये टाइम आउट हो जाता है. So ये क्या करेगा? ये दोबारा से सीक्वेंस नंबर 92 with 8 bytes of data भेजता है. ठीक है? Now this time around इसने एक ही भेजा दोबारा. It just retransmits the segment with the lowest sequence number 92 को ही दोबारा भेजता है. And इसके बाद it receives this ACK 100 जिससे क्या है कि it slides the window forward and sets the send base to 100. It then receives ACK 120, which slides it further to 120. So the window is slid to 120 at the transmission side. ठीक है? तो ये ACK 120 already यहाँ पे पहुंच गया. अब दोबारा से ACK 120 इसको दोबारा से मिले. So it's getting a duplicate ACK for 120. उस पे कुछ नहीं होगा. Nothing is going to slide forward further because it's already received कि अच्छा जी 120 तक सही data. The receiver is expecting 120. The receiver is expecting 120, so it won't slide it forward. It knows that it's received a duplicate packet, जिसकी वजह से ये 120 ही वापस आ रहा है आपके पास. ACK 120 वापस आ रहा है. ठीक है? So premature timeout के केस में आप retransmission करेंगे of a segment with the lowest sequence number that you have. Okay? Any questions here? So these make up some very nice scenarios which often हम पूछते रहते हैं कि अच्छा जी sequence number 92 इतने bytes of data ACK वापस आएगी उसका क्या number होगा. ठीक है? So that's a typical kind of a question that is often asked. Now, here's another case where you have a cumulative ACK. So how does this work? You send segment sequence number 92, 8 bytes of data, send sequence number 100 with 20 bytes of data, ACK 100 जो है वो गुम हो गई. लेकिन इसके मिलने पे उसने ACK 120 भेजी. ACK 100 गुम हो गई and आगे की ACK 120 इसको मिल गई. So it knows that even though it's not got the intermediate ACK, it's got the next one because it's a cumulative ACK. It knows कि अच्छा 120 तक receiver को, the receiver is now expecting 120, तो 119 तक receiver को सारा कुछ ठीक मिल चुका है. तो ये जब अगला पैकेट भेजेगा, अगला सेगमेंट भेजेगा, it's going to start with sequence number 120. ठीक है? So although it didn't get ACK 100, it still is going to start off with sequence number 120. Okay. Now, there have been different RFCs, and these have basically looked at different events at the receiver and what the TCP should do. So if you have an arrival of in-order segments with expected sequence number, that means that all data up to the expected sequence number has already been acknowledged. तो उस केस में, ठीक है, you don't send back an acknowledgement directly straight away. You delay that acknowledgement, wait half a second for the next segment. If no segment arrives, then you send the ACK back. Okay? So over here, these are sort of actions which were suggested in different RFCs, and what they do is provide for greater efficiency. Now, how is that? Well, अगर आप हर एक segment मिलने पे उसको ACK के साथ respond करते हैं, तो there, of course, what is happening is that for every segment that you receive, you're generating data back to the sender, acknowledging that. Whereas if you could batch your responses together, let's say आपको 3-4 segments मिले हैं, 2 segments मिले हैं, और उनका एक ACK आप वापस भेजते हैं, so then the number of ACKs that you're sending to the sender, sending back to the sender, वो कम होंगे. So that is reducing the activity or the actual number of packets that you are exchanging between the transmitter and the sender. Now, why is that useful? It's useful because if you notice, you've got data, and then you have these ACKs. These ACKs are basically, they don't contain any data, they're only control messages. ठीक है? लेकिन इन control messages को भेजने के लिए भी आपके पास एक TCP header होगा, फिर एक IP header होगा, फिर एक frame header होगा. So although you have no data, it's only a control message, you still are going to create an entire frame with a frame header, IP header, TCP header, and transmit that from the receiver back to the sender. So in order to not have that many control messages exchanged, okay, in order to have greater efficiency, what you do is कि जी अगर आपको in order segment मिली है, you wait half a second. And if you wait half a second for the next segment, अगर next segment ही मिलती है तो इन दोनों का आप इकट्ठा ही response वापस भेजेंगे. अगर नहीं मिलती फिर आप ACK भेजते हैं. ठीक है? So if you have an arrival of an in-order segment with expected sequence number with one other segment that has the ACK pending, so you're going to immediately send a single cumulative ACK acknowledging both of the in-order segments. ठीक है? So this results in greater efficiency. कि एक segment मिली, आप ACK फौरन नहीं भेजेंगे, you'll wait half a second. इस half a second के दौरान अगर अगली ACK भी मिल गई आपको, अगला सेगमेंट भी मिल गया, तो दोनों ACKs को इकट्ठा क्यूमुलेटिवली एक ही कंट्रोल्स मैसेज के जरिए, एक ही ACK के जरिए से you're going to send back. Okay? Now, if you have an arrival of an out of order segment higher than the expected sequence number, in other words, you detect a gap, so you immediately send back a duplicate ACK indicating to the sender that you have received an out of order segment. And this is the sequence number that you are actually expecting. ठीक है? इसी तरह से अगर आपको एक segment मिलती है which partially or completely fills a gap in between, ठीक है? Then you immediately send back an ACK provided that the segment starts at the lower end of the gap, which means कि अगर gap में lower end पे segment आपको मिल रही है, so that means that आप अपना base receive base को आगे slide कर सकते हैं, एंड जो ही आप उसको स्लाइड करते हैं, you let the sender know that this is the next sequence number that you are now expecting. Okay. Now there's something called TCP fast retransmit, and in fast retransmit, what happens is that if the sender receives 3 duplicate ACKs, okay, if the sender receives 3 duplicate ACKs, then it knows that something has gone wrong. Okay, it knows that the receiver is receiving segments, इसी वजह से तो आपको वापस डुप्लीकेट मिल रहे हैं, तो इसको ये तो पता है कि रिसीवर को मिल रहे हैं, लेकिन इट नोज दैट समथिंग गॉट मिसिंग, एंड उसके बाद अगली सेगमेंट मिली तो डुप्लीकेट पहला आया, उसके बाद अगली सेगमेंट मिली उसको डुप्लीकेट दूसरा उसने भेजा, उसके बाद तीसरी मिली डुप्लीकेट उसने वापस किया. सो इट डज नो दैट, so for example, sequence 92, 8 bytes of data, sequence 100, 20 bytes of data, this got dropped. आगे की सेगमेंट्स आपने भेज दी. अब हुआ ये कि पहला रिसीव होने पे आपने कहा कि अच्छा 92 सीक्वेंस है, 8 बाइट्स डेटा मिला उसको, it says I now expect the segment starting with data 100. ये इसने भेजा. वो जो था 100 वाला वो रास्ते में गुम गया. उसके बाद कि आप मिलते जा रहे हैं, और जो ही वो अगले मिलते जा रहे हैं, on each one it's sending back, मुझे तो 100 वाला चाहिए, मुझे तो 100 चाहिए, मुझे तो 100 चाहिए. ठीक है. So on receiving packets which are out of order, and ये आगे के पैकेट्स मिलने पे it still sends back ACK 100, ACK 100, ACK 100. तो एक ओरिजिनल ACK 100 and 3 duplicates. तीसरे डुप्लीकेट पे यानी चौथे ACK 100 पे it's going to retransmit this ACK 100 because it knows that something has gone wrong. वो नहीं मिला, आगे के मिलते जा रहे हैं. इसका मतलब ये है कि कनेक्शन तो ठीक है, ऐसा नहीं कि कंजेशन है सीवियर किस्म की, वो कहीं गुम हो गया होगा. So rather than waiting for the timeout to take place, one algorithm is that you immediately retransmit this sequence 100 वाला जो segment था, उसको आप दोबारा से फौरन से भेज देते हैं तीसरे डुप्लीकेट मिलने पे, because the third duplicate is indicating that subsequent segments are arriving fine. वो वाला अभी तक नहीं पहुंचा, so in all likelihood वो बाद में भी नहीं पहुंचेगा. Rather than waiting for a timeout, ठीक है, the fast retransmit mechanism is an algorithm suggested कि जी आप 3 डुप्लीकेट्स मिलने पे यानी चौथा ACK of the same number मिलने पे उस पैकेट को, उस सेगमेंट को फौरन से दोबारा भेज दें. Okay? Any questions here? What is fast retransmit? Fast retransmit is simply a mechanism. ठीक है जी. So the question is, won't this cause more congestion? It wouldn't cause more congestion because आगे के segments तो मिल रहे हैं. ठीक है. All you're doing is the one that is missing, because you received the 3 others after that, and इस सारे दुरानिये में इसको ये 100 नहीं मिला. अगर ये मिल जाता तो फिर ये अगलों के लिहाज से भी it would have sent cumulative ACK back. Cumulative ACK वापस नहीं आ रही है, वो 100 के ऊपर ही stuck है. So in all likelihood that 100 must have got lost along the way. ठीक है. So it won't cause more congestion. What's happening is that you're simply retransmitting that one, the 100 one again. ठीक है. Now, you're not really spamming the network with multiple ACKs. What you're doing is on receiving a segment, आप एक ACK वापस भेज रहे हैं. लेकिन होता ये है कि अगर तो ये मिला आपको और half a second के अंदर आपको अगला ACK नहीं आया, तो फिर तो आप वापस करेंगे इस ACK को anyways. ठीक है. But if you're receiving an ACK you're receiving a segment which is out of order, so then you need to tell the sender straight away कि जी I'm receiving something out of order. ठीक है. And if the sender has received 3 of these, कि 3 out of orders उसको receiver को मिल चुके हैं, that tells the sender that something has gone wrong because it's already received 3 out of order ones. So before the timeout, it is retransmitting back the original one. ठीक है. Any questions here? So notice कि जहां पे आप let us say एफिशिएंसी ला सकते हैं कि जी एक पैकेट मिला आपको, वही मिलना चाहिए था, इट वाज इन सीक्वेंस, आप फौरन से ऐक वापस नहीं भेज रहे, आप ऐक को हाफ अ सेकंड डिले कर रहे हैं, ताकि अगर कोई मजीद आ जाए तो दोनों को इकट्ठा आप एक्नॉलेज कर दें। लेकिन जब आपको कोई चीज आउट ऑफ ऑर्डर मिल रही है तो आप इमीडिएटली डुप्लीकेट ऐक भेज रहे हैं, टेलिंग द सेंडर कि कोई गड़बड़ हो गई। एंड the fast retransmit, what it does is that if the sender sees 3 duplicate acts, it knows that in all likelihood one packet in between has gone missing, and the act numbers indicate कि अच्छा कौन सा packet has gone missing. तो वो उस particular packet को, उस particular segment को दोबारा से retransmit कर देंगे. Okay. Okay, so flow control is very straightforward. The application process is going to write to the TCP socket. ठीक है, आपके पास you have a receive buffer and उसके नीचे code है, and then you've got the IP layer below that. So this is the receiver protocol stack. So when the receiver protocol stack receives data from the sender, it's going to push that up to the receive buffer. अब रिसीव बफर पे जो चीज आ जाती है उसको एप्लीकेशन प्रोसेस अपनी तरतीब से पढ़ता है। तो जब डेटा रिसीव होता है, यू फिलिंग अप द रिसीव बफर, but the application process is then pulling out the data from the receive buffer, and so the receive buffer बढ़ता जाता है as you receive more data, and the application process reads out that data, and the receive buffer will have lesser and lesser data. ठीक है? Now these are two independent things. Data sender से आ रहा है, and application process data TCP buffer से पढ़ रहा है. अगर application process slow है and TCP receive buffer से data नहीं पढ़ रहा and पीछे से data आता जा रहा है, तो you're going to have trouble then. Your buffer is going to overflow here. ठीक है? So even though your network is not congested, if your receive buffer is overflowing, so then that data is going to get lost. So you have to tell the sender to slow down because my application process is slow. So you only allow the sender to transmit enough data that your receive buffer does not overflow. So that means that you're telling the sender to slow down so that it does not overwhelm the receiver because the application process is slow. This is called flow control. So you can think of this कि आपका receive buffer का एक certain size है, you've got buffer data, and then you've got free space in the buffer. So you keep on telling the sender कि जी ये जो receive window है आपके पास, this is the maximum free space available to you in the receive buffer. ठीक है, that's the free buffer space, and that is called the receive window. ठीक है, so आप जब acknowledge करते हैं, you're sending back the control message, you specify कि receive buffer का क्या size है. Initially it's set to about 4 kilobytes, and जो आपके पास ये कम या ज्यादा होता जाता है, आप हर एक acknowledgement में बताते जाते हैं कि receive buffer क्या क्या size है. So the sender does not send at any time more data than is available, more data that would यानी free buffer space से ज्यादा data वो नहीं भेजेगा. So free buffer space at any given time, let's say 3 kilobyte रह गया, so the sender is not going to send more than 3 kilobytes because it knows कि इतनी जगह ही नहीं है receiver के पास to handle that. So basically, this mechanism of providing feedback to the sender कि receive window size क्या है ensures or guarantees that the receive buffer will not overflow. ठीक है? Okay, so the next topic is connection management, and we'll cover that inshallah very quickly. But congestion management mein the key thing to understand is that you have these processes running on the end systems, on the end hosts. So as such, koi taar nahi bichai jati. There's no connection like a dial-up connection that you have in a telephone network or a circuit switch network, as it's called. Basically, it's the connection management is only maintenance of state in the end hosts. ठीक है? And उसमें जो states हैं आपके पास, वो यही है कि अच्छा before data is exchanged, the transmitter and the receiver, the sender and the receiver agree to establish a connection. So it's just like this: कि you tell the the receiver कि जी I'm going to be transmitting something, this is what my initial sequence number is going to be. वो कहते हैं हाँ जी ठीक है मैं तैयार हूँ. This is if I'm also going to, so you request for a connection, वो आगे से acknowledge करते हैं हाँ जी ठीक है मैं तैयार हूँ. It's a two-way connection, so वो आगे से भी कह सकते हैं हाँ जी मैं भी आपको डेटा भेजूंगा. So it requests for a connection from the other side and it specifies its sequence numbers. ठीक है, और आप उसको respond कर देते कि हाँ ठीक है मैं भी तैयार हूँ to receive that connection. ठीक है. So it's just like this कि you say okay let's talk and the other guy says okay this is a two-way handshake. So you initiate a connection and वो उसको confirm करता है. This is called a two-way handshake. ठीक है. Now will a two-way handshake work? Think about this. You have multiple hops in between. You could have variable delays. ठीक है. It might work. It might not work. And we'll see कि क्या scenarios हैं कि जब ये connect करेगा और नहीं करेगा. But the way it works here is ये कहते हैं हाँ जी I would like to set up a connection. This responds and okay, so we'll get back to this inshallah in the next class in more detail. But we'll see that TCP uses something called a three-way handshake to initiate a connection, and we'll see why we require a three-way handshake and why a two-way handshake will not work. Or फिर handshake में क्या steps involved हैं, and how is this actually signified? Okay. Any questions? Any questions? Okay, so thank you very much. Thank you.